a YouTube video for this, and Vishnu was going to present it for me. Visible. This has generated numerous calls to city officials from concerned citizens. The Fillmore Street Bridge over Monument Creek in Colorado Springs spans a jogging path from which seriously tilted rocker bearings are visible. This has generated numerous calls to city officials from concerned citizens. The bridge has other problems. Asphalt covering the expansion gap between the bridge and the east abutment continually breaks up. This was being managed with frequent patches. Colorado Springs engineers wanted to better understand both these problems before investing in a permanent fix. They therefore contracted with Structure Inspection and Monitoring to produce monthly reports for a year, analyzing data from different sources. This contract has recently been extended to a second year. The different sources include land survey records of multiple points on the bridge, inclinometer results from 20-meter test holes drilled in the pavement 10 meters from each end of the bridge, and real-time data collection designed and installed by SIM. Two sources of the problem have been considered. First, a high water event roughly 35 years ago seems to have tilted the middle pier slightly, creating a permanent tilt to its rockers. Second, the west hill may have slumped during a particularly wet year, pushing the west abutment and the bridge into the east abutment. Then thermal motion of the bridge pushed the abutments apart. To evaluate this, we installed 12 linear displacement sensors to measure horizontal motion of the bridge, plus soil moisture and temperature probes at the north and south ends of each abutment, plus one temperature probe in the middle of the bridge. A custom-designed solar-powered data acquisition and communication system collects one observation per second and relays it to the SIM cloud for real-time analysis. The most important finding so far is that 10-minute trimmed means of the motion of the bridge relative to the middle pier is correlated 0.98 with the single bridge temperature measurement. However, the east abutment expansion gap is only correlated 0.90 with temperature and 0.92 with the motion at the middle pier. The lower correlations with the expansion gap suggest possible movements we do not understand, either of the bridge or the east abutment. Possible explanations for this include differential heating or flexing of the bridge and motion of the east abutment. The city engineers asked us to investigate this further, including installing accelerometers and more temperature probes. In the meantime, our monitoring results to date have convinced city engineers that the situation seems sufficiently stable to justify work to improve the expansion joint. Our work on Fillmore and elsewhere has helped us to understand an important problem that must be solved by SHM designers, namely the proper distribution of data processing between sensor nodes, data concentrators on the structure, and a data center where data are stored. With some wireless sensors, data communication can consume over 80% of the power. In this context, we can get more useful information from a given budget by fitting models at the sensor node and pushing only compressed versions of the results to the data center. This can save money both in the cost of sensors and data communication and in the need for storage at the data center. SIM Diagnostic Software is designed to solve these problems. We intend to make the SIM Diagnostic Software widely available to SHM designers, researchers, and engineering students worldwide. The design and documentation of the software will make it as easy as possible for users to follow the 9-step process for developing a structural health monitoring system, described in the Graves, Rents, Rust contribution to the proceedings of this IWSHM conference. More information is available through www.structuremonitoring.com or by direct communication with SIM. We wish to thank the city engineers in Colorado Springs for their support in this effort. Okay, the video, by the way, will be available at via our website and on YouTube. Probably not today, but certainly by next week. Thank you.
We might have time for a question or a comment from the audience. Thank you.